Hey guys, welcome back to another video. Today we're going to be looking at Leetcode 875, Koko eating bananas. This problem description tells us that we're given that Koko, we're not told who Koko is, but we can assume Koko is a monkey that loves to eat bananas. And there are n piles of bananas, and the ith pile has piles I bananas. Okay, and the guards have gone and will come back in h hours. So, of course, our monkey wants to eat as many bananas as they can. And Koko can decide her bananas per hour eating speed of k. Each hour she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead, and will not eat any more bananas during this hour. But wait a minute, Koko likes to eat slowly, but still wants to finish eating all the bananas before the guards return. Return the minimum integer k such that she can eat all the bananas within h hours. So this kind of seemed like a greedy problem, and it is greedy in a way, but we will be using binary search to solve this. I'm just going to jump straight into that because it did confuse me at first, but to solve this problem, we really want to be using binary search, and we'll look at an example why that is the case. So in this example, the output is 4, k is 4, okay? So actually, let's write down something. So we know, we know Koko is a monkey. We know that the gods will come back after h hours, want to eat all bananas, but as slow as possible. And this Koko chooses her speed, and this speed is equal to k. Okay, so in this example, k is equal to 4. And why does this work? Well, let's say 3, 6, 7, 11. So this, we're going to jot down the piles of bananas here, and we can say, well, 4, 4 is greater than 3, so we just consume the entire pile. Actually, let's set this to 1. And this example, we consume 4 of 6 from the pile, and then we plus 1. We add we consume what's left, and then we wait. So when we finish all bananas, we won't eat any more bananas, so it doesn't carry over. We basically just stop eating more bananas. So what we'll do here instead is say this is going to be equal to 2, and the same thing here. We'll eat 4 bananas, and then we'll eat the last 3, and then we will wait for the next hour. And this example, same logic, but it's going to be 3, and then we'll have an output of 8, and that turns out to be 8 hours until the gods come back. So this is amazing. We can finish all the bananas. Koko can finish all her bananas, but she can do so as slow as possible. But again, still finish them off. So that's basically the problem explained. What does this tell us? Well, let's look at some examples of k, right? So k can be k can be 3, for example. Would 3 work? Well, no, because if we calculated that out, it would be 10 hours before Koko would finish all the bananas. By then, the gods will come back, and I assume the gods won't be very happy. So what we want to do instead is say 3 won't work. 3 won't work. No, let's write 3 will not work. Okay, 3 won't work. What about 4? Well, we know 4 does work. 4 will work. And by extension, 5 will also work. 6 will also work. But they aren't going to be the results, right? They aren't going to be the results we want, because we want to return the slowest time, not just the fact that we can eat all the bananas, because then we could just pick the biggest number. If the pile is 11, we could just eat all bananas like that. No, that's not what we want to do. Instead, we want to choose the slowest time. So that turns out to be 4. And you can see if we plot this on like a number line, for example, we have just x's, a bunch of x's, and then some ticks. So we can basically find out, like a midpoint. And this midpoint here is going to be, we'll have a function, we'll have like a black box function that just returns a Boolean, true or false. Can Koko finish bananas at this speed? Okay, we'll pass in the speed and we'll get a Boolean, yes or no. Well, can Koko finish eating bananas at this speed? Yes, she can. But it could be, the midpoint could be here, right? And then we want to look left. If we can, then we want to, if Koko can finish eating all the bananas at this speed, we want to look left. We want to find a slower speed, right? If it turns out somehow, this is going to be the midpoint. Well, then we want to look, the speed is too slow, we want to look for a faster speed. So that's basically the logic behind solving this. Let's actually get to coding. So the first thing we want to do is create our black box function, right? We can give it a speed, and we'll call it canFinish. We'll give it a speed. So that's going to be k. It's going to be an integer. And we want to just return a boolean. We want to return yes you can, no you can't, Koko. So hours is going to be equal to 0. And for each p in piles, actually let me just import math over here so our life is a bit easier. If you don't like to do integer arithmetic, so we can say hours plus equals math.ceiling k divided by p, or actually p divided by k, not speed divided by the pile divided by the speed, and then we want to say, well, let's return, is hours less than or equal to h? If it is, then we return true. Koko can finish. So now we've created our function, our little nice black box help function. We can set our left and right pointers. What's our left pointer going to be equal to? We could start at 0, but then we would just mess up the integer division, right? 0 divided by 0 would just be 0, and or 0 divided by any number. So we basically are we want to start off at a whole number, right? We want to start at 1. I'm going to start from 1. Well, actually a non-zero integer, excuse me. So we want to start at 1, and we want to, the maximum is going to be the maximum, the biggest pile, not piles, we don't want to overdose Koko, we want to choose the maximum pile. Okay, so while left is less than right, mid is going to be equal to, and we're just going to get left plus right divided by 2. And if Koko can finish, so if canFinish, pass in the mid pointer. Well, now we want to look on the left-hand side, right? We want to say Koko canFinish, right is going to be equal to mid. Otherwise, we want to set the left pointer equal to mid plus 1, and then just simply return the left pointer once it's done. So, if Koko can't finish, well, then we want to look on the right-hand side, we want to look for a slow speed. So then we just want to, we want to look for a faster speed because the speed is too slow. So then we just return left pointer. The left pointer is going to be where our correct speed is going to be at, and that's going to be the speed Koko would like to use to eat all bananas before the guards come back. So let's submit our code. Let's check it works, and it does. It passes all 127 test cases. In terms of time complexity for this problem, well, we can derive that the time complexity is big O of n log m. So big O of n log m, and that's basically where n is the number of piles, and m is the number m is going to be the max pile size. Okay, space complexity is going to be big O of 1, just constant space. So with that being said, guys, I hope you enjoyed this video. A bit confusing. The hardest part here is figuring out that it is binary search. Once you figure that out, solving it is not so hard. And with that being said, guys, I hope you enjoyed this video, and I'll catch you in the next one.